halides of these ones. So SF6 ka let us see the hybridization. So in this case hybridization of it would be sulfur has 6 electrons and 6 fluorines are connected over 2, which gives me the 6. So 6 means what's the hybridization? sp3d2 is the hybridization. In SF4, SCl4, SeCl4, so we got 6 plus 4 over 2, right? So it adds to 10, so that means hybridization here is sp3 dehybridized state. So in this case sulfur 6 plus 2 over 2, 6 electrons, 2 halogens by 2, so this gives me what? 4, right? So 4 means what is the hybridization? sp3 hybridized state. तो इसमें सेंट्रलाइज्ड आइटम नहीं है, इसमें हाइब्रिडाइजेशन डिफाइन नहीं होगा. सो दिस थिंग्स वी शुड रिमेंबर. एंड SF6 is in sp3d2 structure and it has octahedral geometry. It is octahedral. SF4 చెప్పాలి. What is the structure of SF4? SF4 or SCl4. So its shape is seesaw. Geometry again the same. Geometry is octahedral. Geometry is octahedral. Shape is again seesaw होता है. तो इसका स्ट्रक्चर भी आपको ड्रा करना है. बोलिए, how many lone pairs are there? How many lone pairs can you find here? How many lone pairs can we see here? So sulfur के पास, sulfur has got how many? तो sulfur के पास how many electrons are there? Sulfur has 6 electrons. Out of 6, how many are used? 4 are used. 4 bonds are formed. So it is left with one lone pair. It is left with one lone pair. So seesaw geometry would be, so you got sulfur connected at the center. So यहाँ पर सल्फर बैठेगा, यहाँ एक क्लोरीन, यहाँ एक क्लोरीन. सो इधर एक क्लोरीन, यहाँ और एक क्लोरीन होगा. So here is the chlorine, here is the chlorine, and here is the lone pair. Lone pair is present here. So if you check the structure of it, so it looks like trigonal geometry, looks like, sorry, geometry తప్పు రాశానండి. geometry octahedral కాదండి, sp3 dehybridized state కదా, sp3 dehybridized state. So it should be trigonal bipyramidal is the structure, geometry. I erase this one, right? So this is the structure. So lone pair is in present at the what position is it? So equatorial position में lone pair present है, and this is looks like seesaw, right? Don't get confused. Geometry पूछा है, trigonal bipyramidal. Geometry is based on only hybridization. The hybridization is sp3d. Shape is based on hybridization as well as the lone pair. Yeah, next we'll go to dichlorides. So like SCl2. SCl2 has got, so kitna lone pairs hai? 2 bonds are there. So it is in this situation, and there are 6 electrons are there with sulfur. 2 are used up. So we end up with the 4. So 4 by 2 equals 2. 2 lone pairs are present. So 2 lone pairs are present on the sulfur in this manner, right? So it's bent V shape में होगा, bent V shape में होता है sulfur dichloride, right? So we'll see here the same thing is we have to study here. Yeah, the reactivity towards halogens. So elements of 16th group form large number of halides of type EX6, EX4, EX2 type of halides, where E is an element of 16th group and X is the halogen. The stability of the halides decreases from the order of this. This is the order you should remember. What is the meaning of this point here? If I write SF4 and SCl4, which one do you think the most stable here? So which one is more stable? I got two compounds SF4, SCl4. So it follows this order. According to this order, fluorides are stable. So SF4 is most stable than SCl. Reason क्या है? Fluorine forms a strong bond and it's close to the sulfur. That's why the stronger bonds are formed here. That's why fluorides are more stable. The stability order decreases in this order. Yeah, among hexahalides, hexahalides are very few known here. Among hexahalides, hexafluorides are only stable compounds. This point you should remember. మనకు తెలిసింది ఒకటే నమ్మ ఇక్కడ. సో hexafluoridesలో తెలిసింది ఒకటే ఒక కాంపౌండ్. What is that? SF6. SCl6 is not possible. Why? Because in sulfur hexafluoride, 6 fluorines can be accommodated around the sulfur because the size of sulfur is bigger and fluorines are smaller. They can be organized in this manner. But in sulfur case, so sulfur is bigger and so is chlorines also bigger. So it's not possible for us to place 6 chlorines around the one sulfur. That's why this is not known. So SCl6 is not known, only SF6 is known. That is the point mentioned here. Are only stable. All hexafluorides are gases in nature. They have octahedral structure. The sulfur hexafluoride is exceptionally stable for steric reasons. Right? So this is about halides, and few more points also mentioned here. Amongst tetrafluorides, SF4 is a gas, selenium tetrafluoride is a liquid, tellurium is a solid. These fluorides hybridization is sp3. The hybridization is sp3 and thus have trigonal bipyramidal structures in which one of the equatorial positions is occupied by the lone pair of the electron. This geometry also regarded as seesaw geometry. This is regarded as seesaw geometry. All elements except oxygen, all elements except oxygen, dichlorides, dibromides are formed. So are formed. These dihalides are in sp3 hybridized state. Hybridization thus have tetrahedral structure, and the well-known monohalides are dimerized state. So all these are the monohalides: S2F2, S2Cl2, S2Br2, Se2Cl2, Se2Br2. These dimeric halides undergo disproportionation as given. So this disproportionation reaction you should remember. Right? So monohalides are very unstable and they disproportionate to give these kind of structures. Right? So here I'll rewrite the reaction. डिस्प्रपोर्शनेशन रिएक्शन कैसे लिखना चाहिए, सबका लिखना आना चाहिए आपको. So the given is selenium selenium monochloride undergoes disproportionation, which gives you selenium tetrachloride and selenium is formed. So in this case, selenium is in +1 state, here it is in +4 state, it is in 0 state. The selenium has been oxidized here, the selenium has been reduced here, right? So this is the oxidation, this is the reduction. If the same element undergoes oxidation and reduction, so obviously the reaction is called as a disproportionation reaction, right? So this is about the general properties. Okay, so we'll go to next part, oxygen. So we'll start with the oxygen. How can we prepare the oxygen? How can we react it? Yeah, we are starting with the dioxygen. Dioxygen O2. The major source of dioxygen is the atmosphere air, because around 20% air contains oxygen only. So 20% is very much higher, that's why the 20% oxygen is present in the air. So we can also produce this one in our laboratories. So in laboratory, how can we prepare? So we can prepare the dioxygen in the laboratories by simple methods. I'll give few examples which we have already seen in somewhere else, right? So we got H2O2, hydrogen peroxide. When decomposed, it gives you H2O and oxygen gas is released. Simple oxygen gas is released. So we can balance this reaction like this. Hydrogen peroxide is an unstable peroxide. Whenever it is heated, so immediately oxygen gas is released by it, right? In the same way, we have got metallic oxides of heavy metals. Heavy metal oxides like silver, copper, mercury, right? Even the gold. So these oxides of these metals are considered as heavy metal oxides. Heavy metal oxides, when heated, they produce oxygen immediately. They will produce oxygen easily, they produce oxygen. So they are going to produce oxygen. So here you get silver plus oxygen is released. Even you can take the copper oxide, which can also be converted into copper plus oxygen. Even the mercury oxide is Hg2O2. So this also decomposes to give Hg plus oxygen, right? And most famous oxygen preparation reaction is KClO3, potassium chlorate. Potassium chlorate, when heated, so it decomposes to produce KCl and oxygen. Oxygen gas का production करता है. So these are the few preparations of oxygen, and majorly oxygen is a byproduct of electrolysis. So in electrolysis of water also gives you oxygenate anode. So H2O on electrolysis gives you hydrogenate cathode, oxygenate anode. So these reactions are also very well known. Half a mole of oxygen is released. So this reaction is electrolysis process. These are some preparations of oxygen, right? And we know that oxygen is thermally stable, right? Oxygen is very much used. We know it, how the importance of the oxygen in our daily lives, because it is the gas which is responsible for all the oxidation reactions taking place in our human body. And due to this oxidation process only, we are able to produce, or we are able to convert our food into energy. So due to which only we are converting our food into energy. That's why oxygen plays major role. And oxygen is also major byproduct in the photosynthesis process, where CO2 reacts with H2O. So in presence of what? Sunlight and chlorophyll. Sunlight and chlorophyll. So we will be getting C6H12O6 and oxygen gas is also released here. This reaction can be balanced by means of what? We know how to balance the reaction. This is another major reaction which conserves the oxygen percentage in the atmosphere, right? So these are the reactions given here. We'll check these ones here. Preparation of oxygen. Dioxygen can be obtained in laboratory by following ways, right? So by heating oxygen containing salts such as chlorates, nitrates and permanganates gives us oxygen. KClO3, when heated, oxygen is released. Silver oxide, when heated, gives you the oxygen. Lead oxide gives you the mercury oxide also gives you the oxygen. These are the lead oxides which also produce oxygen. So this is mixed oxide, this is lead dioxide. So they also produce oxygen gases. Hydrogen peroxide gives you the oxygen gas as well. Okay, the large scale of it can be prepared from water or air. You see here, so water nunchi etla తీసుకొస్తాం, we use electrolysis process. Using electrolysis, oxygen is produced from this, whereas air contains 20% of it. So by oxygen concentrators, they can produce this one. Electrolysis of water leads to release of hydrogen at cathode gas and oxygen gas at anode. Industrially, dioxygen is obtained from air by first removing the carbon dioxide and water vapors, then the remaining gases are liquefied, fractionally distilled to give dinitrogen and dioxygen. So nitrogen dioxins are then separated. Some physical properties are mentioned here, we just will read it out. Oxygen ka properties we have been studying since we are doing the chemistry from class 7th or 8th. Dioxygen is a colorless, odorless gas. Solubility in water is to the extent of 3.08 centimeters in 100 centimeters. This point to be noticed here. So 3.08 cm cubed means milliliters dissolved per 100 ml of water. 100 ml lo enta percent untundi? So almost 3% of oxygen gets dissolved in the water. That's why the aquatic life is able to breathe oxygen through the dissolved oxygen only. The fish in the water needs oxygen. It takes the oxygen from this only, right? Right. So few more points. The water at 293 Kelvin. 293 Kelvin is 25 degrees Celsius. So which is just sufficient for vital support of marine and aquatic life. It liquefies at 90 degrees Celsius and freezes at 55 kelvins. Okay. The oxygen atom has three stable isotopes, namely 16, 17 and 18 oxygen isotopes are very well known. Molecular oxygen O2 is unique in being paramagnetic in spite of having even number of electrons. We have studied this, right? So oxygen is expected to be diamagnetic, lekin it is paramagnetic in nature. It is paramagnetic. What is the reason? We have studied this one on the basis of molecular orbital theory, right? So two unpaired electrons are present in the antibonding orbitals, due to which it can able to oxygen ఆగిపోయింది చూడండి. బాలా సార్ కనిపిస్తుందా? స్టూడెంట్స్ కనిపిస్తుందా? ఎవరికన్నా మాట్లాడండి. ఆ రెండు మ్యాగ్నెట్ల మధ్య ఆక్సిజన్ కొట్టుకుంటుంది చూడండి. ఇట్ ఈస్ అట్రాక్టెడ్ బై దిస్ ఈస్ ద పారామాగ్నెటిక్ ప్రాపర్టీ ఆఫ్ ఇట్. Yeah, so we'll come back to our class again, right? So molecular, this point you should remember properly. Many times questions asked. O2 is being a paramagnetic in spite of having even number of electrons. This is explained by the MOT theory, and these things are mentioned here. So we have few more reactions. We have to talk about the oxygen. Oxygen is a very reactive metal, right? So it can react with anything, right? So I'll write few questions here. Oxygen can react with 3-4 things here. So it can react with metals, it can react with non-metals, even it can react with some compounds. So three types of reactions can be seen for the oxygen, right? So we'll see few examples, and these are pretty basic equations which we have been studying since the chemistry is introduced to us. 7th 8th nunche ee equations vastunnai, so we don't have to worry about these equations. Generally these equations are not asked, so you can write it. Sodium plus oxygen gives you sodium oxide, right? Magnesium plus oxygen, aluminium plus oxygen, right? So like copper plus oxygen, so here we get magnesium oxide, here we get aluminium oxide, Al2O3, here we get copper oxide. All metals can react with this. Even calcium plus oxygen also gives you calcium oxide, CaO is formed, and it can also react with non-metals. Oxygen plus nitrogen gives us nitric oxide, oxygen plus sulfur gives us sulfur dioxide gas, oxygen plus carbon gives us carbon monoxide. Of course, carbon monoxide further reacts with oxygen to give carbon dioxide. What else we have? Even nitric oxide further reacts with oxygen and gives you nitrogen dioxide. So these type of reactions are very, very common here. We'll check few reactions here. So it reacts with calcium to give calcium oxide. It reacts with aluminium to give aluminium oxide. It reacts with phosphorus to give phosphorus pentoxide. Carbon plus oxygen gives you carbon dioxide. So this reaction is important. So this reaction is generally carried out in what roasting of minerals में करते. Simple reaction. So zinc sulfide reacts with oxygen and gives us zinc oxide plus sulfur dioxide is formed here, and CH4 plus O2 gives you CO2. All these are pretty basic reactions. So this is the reaction we used in the contact process, and HCl plus oxygen gives you Cl2. So this is one of these important reactions. Yeah, this is about oxygen. So this is preparation, properties, and we'll find the uses. What are the uses of oxygen? Everybody knows oxygen uses. చెప్పాలమ్మా oxygen uses చూడండి ఒకసారి. So in addition of its compounds, its normal respiratory combustion process, oxygen is used in oxyacetylene of welding, in the manufacturing of many metals, particularly steel. Oxygen cylinders are widely used in hospitals, high altitude flying and mountaineering. The combustion of fuels needs oxygen. Hydrogen in liquid oxygen provides tremendous thrust to rockets. So this combustion के लिए we use it. Hydrogens in liquid oxygen gives you tremendous thrust to the oxygens. यहाँ कुछ reactions दिया हुआ है. Okay. So next we have simple oxides. Okay. So what are the oxides, and we'll see about these oxides. Okay. So next thing is about oxides. So the oxides are various types, we know it. This is the general preparation. Metallic oxides, metal oxides, common oxides है, non-metal oxides, non-metal oxides. Next one, amphoteric oxides. Amphoteric oxides, neutral oxides, neutral oxides, mixed oxides, mixed oxides. What else we have? We have one more, metal acidic oxides. Right? So metal oxides, we know it like all the metals, first group oxides like Na2O, K2O, Li2O, magnesium oxide, calcium oxide. All these are the metallic oxides. When metallic oxides are placed in water, they produce strong alkali. So that's why metallic oxides are known as basic oxides. Basic oxides. Non-metallic oxides are oxides of the metals. For example, we have N2O5, nitrogen pentoxide, N2O5, P4O10, phosphorus pentoxide. In the same way, we have Cl2O7, chlorine heptoxide, Cl2O5, chlorine oxides. So if oxygen is present with a non-metal, it behaves like a non-metallic oxide. Non-metallic oxides, we know it, they are acidic in nature. They are acidic in nature. We will see the amphoteric oxides. This is important. The questions are asked on basis of amphoteric oxides. Amphoteric oxides have got properties of both acid as well as base. That's why we call them as amphoteric oxides. So amphoteric oxides లో ఏమేమి వస్తాయండి? So we have a list here. Do you remember? So sub जन की आंसू सुनो, ऐसा कुछ न्यूमोनिक है, आंसू सुनो प्रभु अल्लाह. देख लीजिए, सब अंटे स्टिबियम, జెన్ అంటే జింక్, ఆసు అంటే ఆర్సనిక్, సునో అంటే టిన్, ప్రభు అంటే ప్లంబం, అల్యూమినియం. సో దీస్ ఆర్ ద metals which form amphoteric oxides. All oxides of Sb, so you take Sb2O3, Sb2O3 is an amphoteric oxide, zinc oxide is an amphoteric, arsenic oxide is As2O3, tin oxides are two, we have SnO, SnO2, so both are amphoteric in nature. Lead has two oxides, PbO, PbO2, both are amphoteric in nature. Al2O3 is also amphoteric oxides. సో ఇది స్క్రీన్ షాట్ తీసుకుంటారా మరి రాసుకుంటారా ఒకసారి మీరు నోట్ డౌన్ చేసుకోండి. సో వెరీ వెరీ ఇంపార్టెంట్, విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ ఎన్ amphoteric oxide, which of the following is not an amphoteric oxide? These type of questions are asked. So if you are done with this, we'll go to mixed oxides. Mixed oxides. What is the meaning of mixed oxides? They are group of two oxides, mixed oxides. So mixed oxides lo we'll see about Fe3O4. Fe3O4 is not a simple oxide, it's a mixed oxide. Actually it is the combination of FeO plus Fe2O3. So this is ferrous oxide, ferric oxide, दोनों का मिक्सचर है Fe3O4, right? Next Pb3O4. So this is the mixture of PbO plus PbO2. इन दोनों का मिक्सचर है. So I have to take 2 moles of it, right? Yeah. But you don't write everything in this formula. So we have Mn3O4. So it's like MnO and Mn2O3. So these oxides are known as mixed oxides. When two oxides combine together and form a compound like Fe3O4, this oxide is known as mixed oxide. Pb3O4 is mixed oxide and this is also a mixed oxides. Okay, so this is about the oxides. We'll see the here oxides का nature में check करेंगे. Yeah, simple oxides are given. So these are the things we should remember, and we'll talk about acidic metallic oxides tomorrow. So in tomorrow's class we'll see that. Okay, thank you. We'll